Okay, good morning. Today we are going to be with approximate methods. So we have to go for three approximate methods: portal method, cantilever, and substitute frame method. So we are with portal method today. Now, just I have mentioned we have to go for three approximate methods. Out of these three, two are for your lateral or horizontal loads. Now, these lateral or horizontal loads, these are due to earthquake or wind loads, or are known as due to earthquake or wind. And second, we have that is due to gravity, that is self-weight, we can say that may be live load, or we may have dead load. So that gravity loads we have another. So on the basis of these two and vertical loads, we are going to be three methods. For lateral loads, we have two methods. First method, we have portal method, and the second method, we have cantilever method. And for gravity loads, vertical loads, we have substitute frame method. So by using these methods, we are in position to analyze the multi-story frames easily and within short time. So once we have analyzed, and we are in position to know the dimensions and estimate, we can go fast uh, to give to the customers. And therefore, these approximate methods are used. That is only for your preliminary purpose. So now portal method, already mentioned, used to analyze building frame subjected to lateral loading. Now this method is appropriate for low rise building frames, means when my height is less than width. So when height is less than width, we will go for this portal method. Now in the analysis, we have to go for three assumptions. First, an inflection point is located at mid height of each column. Then second, we have an inflection point is located at center of each beam. That means we have bending moment 0 at this point. That is at mid depth, mid height of column, and at mid span of beam. And third, we have the horizontal shear is divided among all the columns on the basis that each interior column takes twice as much as the exterior columns. Each interior column takes twice as much as the exterior columns. Means shear taken by interior column is twice that of exterior columns. Now we will go for the problems. So first we are with analyze portal frame as shown in figure by using portal method. So now we have this, that is one bay and a two-story structure, and we are interested to draw bending moment diagram, and that we are preferred this bending moment diagram on tension side. Now you can have this. So I can have this as bay. So I have one bay. So we have one bay, and then we have two stories. So we have this will be first story. We have this is second story. Now we can have this ABCD. We have ABCDEF, and then dimensions of the beams and columns. We have 3 meter, 3 meter. That will be bay dimension 3 meter, and column, that is ground floor, we have 5 meter, and upper floor we have 4 meters. Now we can have third assumption. So third assumption, we have interior columns twice that of exterior, but as we do not have any interior columns, we have only exterior columns. So we have value of the shear for both is same, that is H1 and H1. So H1 plus H1, that will be equal to 50, and from this we will get H1 value, that is equal to 25 kilonewtons. Now similarly, we can, whenever we will go for this, we have to consider half part of that floor and above that. So if I will consider this is topmost story, so I have taken only half part of the topmost story. If I will go below it, then I have to consider half part of the story below it, and the above part of it also. Means we have to consider, suppose we have 3 stories, then we will consider first third story half part, then we have second story half part, and above it. Means we have to consider the loads above that level. So now we have this will be level at the center of this, and we have considered above this. So now you can see this. So above this, so I have considered that is mid of ground floor. So I have to consider above that all values, and then we have this will be again H2 and H2, and then we will get it as minus S2 plus 50 plus 70. and that will gives me H2 equal to 60 kilonewton. So we have in this way the values of shear, horizontal shear, which will act on your columns. Then if we will remember your first, then we have that is inflection point at mid span of the beam. So we have this will be at mid span. We have inflection point, means my bending moment at these joints are 0. So if we will cut it from this, then we have actually three reactions, one vertical, another horizontal, third moment. But as inflection point we are considering over here, therefore my moment is 0. This is for your mid span. And then we have these inflection points which are at the mid height of the column or mid depth of the column. Now we have to consider each parts between the inflection point. Now you can see, so we are going to consider, or we will give the names to this. We have A1, B1, C1, D1. These are the inflection points in columns, and we have A2 and C2, the inflection point in beam. Now that letters are you have to decide which letters you have to give for identification of these inflection points. So I generally preferred, that is columns we have 1 and beams we have 2. You can be reverse one. Now we will go A1, A2. Now we have to consider between the inflection point. So we will consider first this part, that is A1, A2. Then I will consider A2, B, B1. Then I will consider A1, C2, and C1. So this T. Then we have this T. Likewise, we have to consider one by one. So now we will go with first. So we have this will be 25 kilonewton. That will be horizontal shear. Then dimensions of this part, and then we have A1, A2. Now we have unknown 3. So we have A1, we have one reaction, that is vertical. Then A2, we have vertical and horizontal reaction, because in portal frame we are going to get horizontal value of the horizontal reaction, which we are going to say as shear taken by the columns. And then we have, this will be values of the VA1, VA1 we have unknown, VA2 we have unknown, HA2 we have unknown. Now unknown in x direction we have only HA2, so we can use summation fx equal to 0, and by applying summation fx equal to 0 we are in position to get the value of HA2. So now we have fx 0, so minus HA2 minus 25 plus 50 equal to 0, and that will give me value of HA2 equal to 25 kilonewton. Now knowing HA2, we can go for moment about A2 0. We cannot go summation Fy 0 because we have two unknown, VA1 also unknown, VA2 also unknown. So by using summation Fy, we are not in position to get the values of this unknown. Then we can have moment about A2 0, and we have 25 into 2, which will be clockwise. So plus minus, because anti-clockwise, VA1 into 1.5, which is equal to 0. That will gives us VA1 equal to 33.33 kilonewton. Now as we are getting value plus, we have considered downward. So assumed direction is correct, and if we will see, we are going to get this VA1, which is 33.33 kilonewton downward. Now apply Fy0. So as it is downward, so VA2 should be upward, and we will get this value 33.33 kilonewton. But this value of VA2, so this VA2 will act in vertically upward direction. So we have value that is in vertically upward. So now you may have question why we have considered downward, because I know if I will take moment about A2 0, so 25 will develop clockwise moment. So I know this should be downward, then only it will develop anti-clockwise moment, which will balance clockwise moment of 25. So if you want, you can consider upward, then change this sign. Better always give the correct direction if you can. So I will prefer VA1, that will be downward, which will balance my clockwise moment due to 25 kilonewton. Now once I know these values, so I will put these values, and we have this will be 33.33, 33.33, and 25. Now we know, so we have this point, this value we are going to get equal and opposite, because we have this joint we have again A2, and so my value should be equal and opposite. So when we will add these two, so our value should be neutralized, and then we will have these values 25, 33.33. And now if we will apply Fy equal to 0 to this, then we are going to get 33.33 upward, and then now you can see we are both in equilibrium conditions. Now once I know these values, then I will go to the next part, which will be bottom story, and then we have 70 kilonewton. Then you can have these values at A1, you have 25 left and 33.33 downwards. So that A1 we will go 33.33 upward, 25 towards right. So that values are shown over here. So 25 right and 33.33 upward. Now this 60 we have already seen, that is horizontal shear. We are going to get H2, which is equal to 60 kilonewton. Now knowing these values, unknown again we have 3, VC1, VC2 and HC2. Now we can go summation fx0 because unknown is again one only, HC2. In vertical we have VC1 and VC2, so we cannot go fy0, we have to take moment. So first we will find value of HC2, and then we will get this value of HC2, and that value we are going to get as 35 kilonewton. So we have HC2 that is equal to 35 kilonewton. Now knowing HC2 value, we can take moment about C2 equal to 0, and then we have 60 into 2.5 clockwise, so plus minus VC1 into 1.5, that will be anti-clockwise. Then we have 25 into 2, which will be again clockwise. Then 33.33 into 1.5, that is also again clockwise, equal to 0, which will gives me value of VC1 166.66 kilonewton. Again I got this value as plus, so I will have this in downward direction, because we have considered downward. Value plus shows your assumed direction is correct. Now why I have given VC1 downward? Now you can see all the other loads are going to develop clockwise moment. So VC1 should develop anti-clockwise, then only it will be balanced. Now once I know VC1, I will apply Fy equal to 0, gives me value of VC2, which will be 133.33 kilonewton. We have considered upward and we got value as plus, so this will be in upward direction. So likewise we are going to get these values. So we have these values 133.33, 35 and 166.66 kilonewton. Now we will consider this part. Now we have C2 over here, then you can see C2, so 35 towards right, 133.33 will be downward. This will be from B when we have 25 towards right, 33.33 downward. Similarly, we have 60, which will be my shear at D1, which will be H2 value. Then we will have these values, and once I know these values, so now you can take moment about any point and you can check it, your moment is going to be 0 or not. Now this 166.66, because I know this is 133.33, which I got from this C2 point, and from B1 point I got this as 33.33. So automatically I will get this as summation Fy0, I will get this value as 166.66 kilonewton. So knowing this value, we are in position to plot the bending moment diagram. We are interested to plot the bending moment diagram on tension side. Now we have likewise, and we have this in this way. So now we will go with first. So we will go first all columns, and then we will switch over to beams. Now we have first columns at A. We are going to get moment due to the load which is perpendicular to that element. So for column, perpendicular is 25. So 25 into 2. So now if I will consider this separately, so if I will consider this AA1. So now you can see we have this as AA1, and moment developed due to AA1, you can see this moment is going to be by 25, this moment is clockwise. Now to balance this, we know we have to apply fixed end moment anti-clockwise, and then all to balance, or we can say final moments, fixed end moments, and this will take, because tension side we have to plot due to fixed end moments. So this will take column inside, so we have this will be column inside. And we have this value, how much? 20 into 2, that is 50. So we have this will be for first column. Second, we are going to get same, you can see over here. So again 25 into, we have this distance again 2 meters. So from this we are going to get 25 into 2, and again we have this value in this fashion. So now knowing this, then we can go to the column which is bottom side. So we are going to be with this. So we have this 60 into 2.5, and that value we have, because now column we have perpendicular. This again, if you will see, you have clockwise, so you have to apply anti-clockwise. That column again go inside, and we have this value as 150. Similarly, we can have last one. So in the same way, we will have this as 150 kilonewton meter. Now knowing this value, we will switch over to the beams. Now you can have this beam value. So now you can go to the beam, means I have to consider the load which is perpendicular to the beam. So we have this load which will be 33.33, because 25 that will act along the axis, so it will act as axial. Now we have this as 33.33, and we have this distance as 1.5. Now you can see we have moment developed due to this. That moment is going to be anti-clockwise, and fixed end moments we are going to get clockwise, and this will take your beam below, because my point, this will be my A point, and therefore at A point, this point, we are going to get this beam that will be on downward direction. So automatically at B it will be upward with value that we have 33.13 into 1.5 is 50. Now for this we have, this will be 133.33. We are going to get it as force which will develop your moment. So 133.33, and we have this distance which is again 1.5 meters. So knowing this distance and this, we are going to get again moment that will be anti-clockwise moment, and to balance it, our final fixed end moment we have clockwise, which will again take your beam that is below at point C, and that value we are going to get as 200 kilonewton meter. So we, in this way we have to draw the BMD, and always keep in mind you have to draw the BMD on tension side, because for design bending moment should always be in tension side. Now we have another problem which will be we have for 2 bay and 2 stories. So generally in examination you will come with example that is of 2 bay and 2 story in university examination. So we have, this is our problem, that is of portal frame, and we have to again analyze by using portal frame method. So now we will have first in the same way. Now here we have interior column. So we have, this will be, this is my exterior column. We have this column as exterior column, and then we have this column as interior column, and then we have twice of exterior, so that will be 2 times, and then we have minus h1 minus 2h1 minus h1 plus 40 equal to 0, and we have h1 equal to 10 kilonewton. So knowing value of h1, we can again analyze by considering each joint. Before that we will also calculate h2 value, and then we have this value h2 2s2 s2, and you calculate it. By calculating this value, we are going to get value of h2 equal to 30 kilonewton. So now we know h1 value, we know h2 value, and then in the same way we have to analyze it. So now we have this, then we have to go for these 3 assumptions. We have first assumption, that is your all beam, mid span of beam, that is inflection point. So we will first go for all beams with inflection point, and then we will go with all mid height of the column as inflection point. So knowing these inflection points, then we have to consider each part separately. So let us, we have column, we have A1 B1 C1, then D1 E1 F1, and for beam we have that is A2, then we have D2, then we have C2, and then we have F2. So we have, in this way, these labeling of the points are most important. But now we will consider each part separately. We will consider A1 A, A2, then we have A2 B, C2, and B1, then we have C2 C, C1. So in the same way we have to consider the portion which is between the inflection points. So now we will start it. So we have first, that is given we have this one, we know this is 10 kilonewton, so unknown we have 3. So first we are again apply fx0. By applying fx0, we are going to get value of ha2, that is 30 kilonewton. Now y direction, again 2 unknown, so we will take moment about a2. By taking moment about a2, I will get value of va1 7.5 kilonewton. Then apply fy0, I will get value for va2, which is again 7.5 kilonewton. Now we will switch over to the B joint. So B joint, again we have this horizontal shear as 20 kilonewton, because interior we have twice of exterior. Then these values, so here we have 37.5, exactly opposite. We have this as A2, this is also A2 point. Then we have, these are the dimensions, and then we have to determine 3 reactions, which are VB1, then VC2, HC2. Now again apply Fx0. Applying Fx0, I will get value of HC2. So knowing HC2 value, I can go moment about C20. So by taking moment about C20, we are in position to calculate value of VB1. So VB1 is 1.5 kilonewton. Now we will apply summation Fy0, which will gives me value of Vc2 6 kilonewton, because now this is 7.5 and I got this value as 1.5, so automatically this will be 6. So addition of these two will be 7.5 in downward. And then we have C point. So we have values likewise, and then we have C points. Then we have at C2 equal and opposite, that is 10 and 6. and now applying summation Fy equal to 0, we have this value as 6. Then you can take moment about any joint, so your value should be 0. Then we will switch out to the next story. So we have D, and at D we have 80 kilonewton, and then same way, so you can have 10 7.5, which we have taken from A1. Then we have to go for three unknowns again. So here again we will go for summation Fx equal to 0, which will gives me value of HD2. So knowing value of HD2, we can have moment about D20. So apply moment about D20. So write down the equation 30, that will develop clockwise. So plus VD1 anti-clockwise, then 10 into 1.5 again clockwise, 7.5 into 2 again clockwise equal to 0. So knowing this value, we will get value of VD1. So knowing value of VD1, we can find value of VD2 also. So now VD1 we have 48.75 kilonewton, VD2 we have 41.25, then we have horizontal force, that is just D2, we have 60 kilonewtons. Then knowing these values, we can switch over to the E point. Now we have D2 values, we will put over here D2 values, B1 values, and E1, because E1 we know 60 twice of D1, because that is interior, that of twice that of exterior. So now knowing these values, we can have this as 20, because now you can apply Fx0. So we have 60 cancels over here, so that 20 will be balanced by this 20. So I directly take Hf2 as 20 kilonewton. Now we can have Vf2. So I will apply summation Fy we cannot apply again, because Ve1 and Vf2 both are unknowns. So we have to take moment about F20, and by taking this moment, we are in position to get the value of Ve1. So now once I know value of VE1, which is 9.75 upward, so we have 41.25 downward, 1.5 we have downward, and then 9.75. So that we will get as 33 kilonewton as value of VE2. So now VF2. So now knowing this value, all values, we can go to the last point, which will be F point. And here we have again C2 value we know, C1 we know, this value 30 because exterior column. So we will show all values, and then just apply Fy0, 33 downward, 6 downward. So automatically this will be 39, which will be upward. And you can take moment about C2 to check it, your calculations are correct or not. Yes, we will get here, you can check it. Now, once we are with these values, then we will go for the bending moment diagram, which will be on tension side. So these are the inflection points, means my bending moment is 0 over here. So you can see now 10 into 1.5. So we have first. Now we are taking for column which is vertical. So my force which is horizontal will develop moment. So 10 into 1.5, which will be 15, and that will be in clockwise. So we have to take find fixed end moment anti-clockwise, which will take column inside. So we have this value as 15. So now once I have this value, then I can go with next, which will be B joint. Now here you can see this column. So we have to consider this force, which is perpendicular to it, 20 into 1.5, which will be 30. Again, that will take column towards right. So we have 30 towards right. So now we will go to the joint C. Now here you can see we have 10 into 1.5 again clockwise. So fixed end moment we have again anti-clockwise. Take your column towards right. So we have this will be again 15 kilonewton meter. Now you can have this next, which will be column D1. Now we have 30 into 2.5. Moment we have to take a D2, and we have to consider this column only. That is, we are not bothering about this, because by this 10 into 1.5, which will be 15 kilonewton meter, which will be clockwise. So to balance it, we have to apply anti-clockwise. This already we have plotted over here. So now 30 into 2.5, that value we are going to get as 67.5, which we will have plotted on this side. Again, column will go inside. Then we will go to the next, which will be joint E, and at joint E we are going to get that 135. So here 60 into 2.25, and 60 into 2.25 we will get 135 kilonewton meter. And last we have joint F, which will gives me again same 67.5 kilonewton meter, that I have not shown over here. Then now these are the bending moment diagrams for your column. Now we will switch over to the beams. Now we have A, B, B, C, and D, E, and E, F. So now I will first go for A, B. So now beam, when we will go, so I have to consider vertical force for the bending moment. So I have 7.5 into 2, that will give 15. Again, this moment will be in anti-clockwise direction. So fixed end moment will be clockwise. So if I will plot bending moment over here, that will be clockwise. So it will take your beam downward. So we will get this 15 in downward direction. Now go to the portion which will be BC. Now BC, you can see again we have at C. This will develop your moment that will be in anti-clockwise direction. To balance it, we have to apply moment which will be clockwise, and that will take your beam in upward direction. So we have this joint as C2 joints, and that will take your beam in upward direction. So we have again this value that will be 15 kilonewton meter. Now we will switch over to the DE. Now in DE, we have to go again for bending moment at D. So we have this will be 41.25. So into 2, that will be 82.5. Again this moment will be in anti-clockwise. To balance it clockwise, that will take your beam downwards. So 82.5 kilonewton meter. And last we have that will be EF. Again EF, you can say 33 into 2.5. So you will get this value again, that is 82.5. that is at point. So this is point. Actually we have this point as F, and we have this value that will be 82.5 kilonewton meter. So we are going to get in this way, that is bending moment diagram on tension side. So thank you. So this will be about your portal method. So today we will stop here only, and in next we will go for cantilever method. So